Recording in progress.
Yeah, Cam's on everyone. Let's start off. The last thing that we did was the net pulling force method, which we used to find the acceleration and the tensions. The only thing is it is valid when all the blocks have same magnitude of acceleration. Great, let's go ahead with a few more. Say this is a block of mass m. This is a block of mass 4m. This is the floor. Initially, both are at a height of 1 meter from the floor. So system is released from rest. So the first question, find acceleration of the blocks. Now here you cannot use a net pulling force method. When you look at them, you get a feeling, right? They don't have same acceleration. The second part. When 4m hits the floor, it stops. Find maximum height reached by the M block from the ground level. There, let's get them. Initially, the system was released from rest. Anish. Let's find the acceleration of the blocks. Remember the process. Don't know how to start. You always start with the process. I3. Okay, let me show you the steps. Step 1, choose your system. So there are 2 of them. Assign tensions. So I will take this string tension to be T. If this is T, then this is also T, and this is also T. Your weight mg, your weight 4mg. Great. Next thing, assign accelerations. Let this go with A1. Let this go with A2. Don't assume they are same. You don't know. And when you see the thing, you are getting a feeling they are not equal. Great. Step 2, assign accelerations and find the relation between them. Use string constraints. So tension into acceleration plus 2 times tension into acceleration minus A2 is equal to 0. So A1 is equal to 2A2. That is a relation. So if that block is going with A, this will go with 2A. If 4M is going with A, this will go with 2A. This is your equation 1. Step 3, resolve the forces and write the equation. Here everything is up only. So for the block, it's T minus mg is equal to mass into acceleration This was your equation 2. The other one is 2t minus 4 mg is equal to mass 4m into acceleration minus a2 because it is down. Then take this a1, substitute here. Then this equation becomes t is equal to mg plus 2m a2. Take this and substitute here. This will become 2 mg plus 4 ma2 minus 4 mg is equal to 4 ma2. That would be 8 ma2 is equal to 2 mg. A2 is equal to g by 4. A1 is equal to g by 2. Have a look at this. You just follow the process. Draw the FBD, assign accelerations, find the relation between them, write the equations, solve. You cannot use a net pulling force method because they don't have same acceleration. So that is one thing. When you want to use a net pulling force method, you have to be really sure like, they are all have same magnitude. And the second part of the equation. So this 4m is coming down, it hits the floor. In this process, m is going up. So what is the maximum height reached by the block m? Try, I'll give you a minute for that. Now the problem has transformed from NLM to kinematics. This is a really good mains question. The acceleration part. Nay, Anish, there's a problem here. Find the maximum height reached by the block. You be clear, na? I told you it is right already. You're right, Anish. See what is happening there. The thing is, this was M. This was 4m, and this was your 1 meter. So this thing initial speed is 0, and this thing has an acceleration a2 is equal to g by 4. So by the time this block comes and hits the floor, look at the picture how it looks. This M block must have gone up. This 2m must have hit the floor. This 4m is hitting the floor. So just before hitting the floor, the speed will be v. This is just before collision. I can use the formula v square minus u square is equal to 2as because acceleration is constant. So v square initially is 0. This is 2 g by 4, and that's 1 meter. So we get v square is equal to g by 2. And just now we saw from constraints, if this is going with v, this will go with 2v. So at this instant, this thing is going with 2v. And in this process, this must have traveled how much? Initially, it was already 1 meter. If this travels 1 meter, this will travel total 3 meters. Make sense? Meaning from this position, right? I think Anish, that is wrong. This is 1 meter. This block must have come somewhere here. So if that travels 1 meter, this will travel 2 meters. But remember, is the velocity 0? No, right? After collision, what will happen? The 4m will stop. The 4m came to rest. But this guy will actually fly in the air, isn't it? Because of velocity, it will fly in the air. The string becomes loose. So it starts flying like a particle projected into the air. After collision, 4m stops, but remember, string cannot push, but m flies up. Tension becomes loose. Your acceleration becomes minus g. So this thing will, so from this position here, it will go up and then come down. So it will fly like a projectile. So this would give you another h max, which is 2v whole square by 2g. How much is that speed? That will be 2v whole square by g. There. So v square is 5. So that would be how much? 4 by 2g into 5. That is 5, 4, 21 meter. So total, it went up 3 meters. So maximum height is 4 meters. From the ground level. Is that clear, everyone? So the point is, when the 4m stops, right, m does not stop suddenly. The m will fly up with a velocity. It will flies up like a projectile, and in this process, the tension in the string becomes 0. So in total, it goes 4 meters from the ground. Because strings cannot push. So the moment this thing tries to go up, the string here will suddenly become loose, isn't it? It will just fly up and then fall down. The string becomes tight again. So that's a problem for some other day. But all clear, everyone. So when the 4m is about to hit the ground, you will travel 2 meters. Because for every 1 meter of 4m, m will travel 2 meters. We got it from constraints. You're already 1 meter above the ground. So when 4m hits the ground, you're already at 3m. And then you'll fly for 1 more meter. All clear with this? There. So that thing, just be careful with that. So it doesn't stop there. That is a mistake. People think it will stop there, but it will fly. Let's see one more. Actually, there was question is there. Okay. Wait, there is one question I wanted to do. I'll do this, then we'll come back to police again. You made a block like this. Theta, theta. This is 2m and this is m. All surfaces are smooth. You're pushing this with 2f and you're pushing this with f. Find the maximum f so that the blocks don't, go above each other. Meaning they should not become like this. Find max f so that m does not climb onto m. Meaning if you apply really a lot of force, there is a possibility it will become something like this. You getting? It can climb on top of it. I don't want this to happen. What is the maximum force you can apply? Let's get this thing. All surfaces are smooth. Let's see how you approach this. So there's no friction between them. There's no friction on the floor. Get it. It's a good one again. It's like not too out of the world. It's not too easy also. So for a mains, it's a really good question. It's a good concept there. Any answers? You got an answer? Do type in the chat box. I'll give you a minute more. Meaning, if I had to give you a hint, ask yourself, when do you know it has climbed up? Or let's ask the other way around. When it starts climbing up, it loses contact with whom? It loses contact with the floor, isn't it? So what can we do? Can you find the normal reaction on this block? And we will use a condition as long as n is greater than equal to 0. That means this guy will be on the floor. The moment it loses contact, n will become 0, isn't it? Isn't that the critical condition? So you have to find a case when this n just becomes 0. The moment that n becomes 0, that means you're losing contact with the floor. You'll start climbing it up. That's the thing there. Now do it. So indirectly, I'm asking you, find this normal reaction n in terms of f, and then put n greater than equal to 0 so that it won't lift off. That should give you the inequality. Because the moment you lift off, you lose contact with the floor. That means n becomes 0. So remember that word. Whenever someone says it loses contact, right? They separate from each other, right? So they're saying n is becoming 0. That's the idea there. So two spheres are losing contact. The wedge is losing contact with the block. Whenever you hear those words, n is becoming 0. mg. I don't remember the answer, but let's see. 3 by 4 mg tan theta. You have mg by sine theta cos theta. You have two different answers. So step 1, draw the free body diagram. I'll draw for them both separately, or you can take them together. It doesn't matter, however you want. So I'll first take them together. So my system is both of them together because they're not flipping, right? So this is 2f minus f is equal to 3m into acceleration. So we get acceleration is f by 3m. Perfect. Then take the FBD of m. Now write the forces. So this would be normal reaction between them. This will be n ground. This is a force F, and this is your own weight mg. And this is your acceleration. So these are the forces on the right side. You could have taken the left side also, but we will take the right one because I want to find this normal reaction. So taking left is useless. Great. And we know this angle is theta. So if you extend this, this angle will be 90 minus theta. So if you resolve this into components, this will be n cos 90 minus theta. So that will be n sine theta. And the vertical component will be n cos theta. So this n is the normal reaction between both the wedges. In the vertical direction, n cos theta is balancing mg. N cos theta, no, there is also one ng also. N cos theta plus n ground minus mg is equal to 0. This is equation 1. In the horizontal direction, we have n sine theta minus f is mass into acceleration. What mass into acceleration is f by 3. So from here we get n sine theta is equal to f plus ma is f by 3. That's 4f by 3. So from here we get normal reaction is 4f by 3 sine theta. Take this guy and put it in the equation 1. Once you do that, that becomes 4f by 3 cot theta plus n ground minus mg is equal to 0. This will give your mg ka value. N ground is mg minus 4f by 3 cot theta. Since you don't want to lose contact, mg must be 0. So for not losing contact, n ground must be greater than equal to 0, where equal to 0 is just a limiting case. This would be mg is greater than equal to 4f by 3. You are right. No, we got it. So then you'll get f is less than equal to 3 mg by 4 tan theta. As long as the force is this much, you're safe. So the limiting case is f maximum when it becomes equal 3 mg by 4 tan theta. Anything more than this, they are going to slide over each other. So the main idea was to figure out when you're losing contact n becomes 0. That's it. That's the main thing about the question. That's what makes it good. And if you see, we followed the process. We did nothing new. FBD equation solve. So you have to be very good with your FBDs. Draw it neatly. Getting it? Don't think it's a waste of time. At least in the beginning, draw them. Maybe after a few months, right, you'll get so used to it, then you can start skipping certain things. But initially, do it properly. Any doubts on the equations, FBD, anything, please ask. Clear? Going ahead. Clear, na, Tanishka? Slow, Anish? Got your mistake? Slow, clear? Rohit? Manav? Clear? Ananya? Let's see the next one. The next one is a good one. We have a block of mass 3m. We have 2m and we have m. Find acceleration of the blocks. Let's get this, everyone. I'll just give you one small thing. Now, technically speaking, you can choose anything as a system. There's nothing wrong with that. But if you want to treat the whole thing as one single block, we have a problem. So here, this cannot be treated as a single block. So keep that in mind. So the idea is this: if you want to treat two things as one block, they should have same acceleration. Same acceleration, meaning magnitude and direction. But if you say, no, I still want to take that as one system, then how do you write? Then we will say, okay, you want to write this is one system. This is acceleration A1. This is acceleration A2. This is mg. This is 2 mg. So I will take this guy as tension T, and this guy as tension T, and this guy as tension 2. So if I treat that as a system, this will be the net force equation. See, 2T minus 2 mg minus mg, this is the net force, is equal to m1 a1 plus 2m a2. This is acceptable. This is what was happening. If they both had same acceleration, I can take out a common, and I would have got m plus 2m, and then it would have become 3m block. You're getting the catch? So you can still write net force is mass into acceleration for both the terms separately. This is fine. You can write this thing, but it's really not much use. So keep that in mind. You cannot treat them as one single block because they have different accelerations. So yeah, right, Anna. Next look. We have one answer. So let me show you this in, let's do this normal. Brute force. We will follow the process. Always the process will be there. It doesn't matter what is the problem. Step 1, choose your system. 3 blocks. Draw tensions and weights. Tension, mg, tension, 2 mg. This has 2 tensions, so this becomes 2T. This is 2T. This is 3 mg. Step 2, assign accelerations. This is A1. This is A2. I don't know how they're going, so I'll just assume any direction you want. I can take even this thing is also going up, but I'll take A3 down. It doesn't matter. You can choose any directions you want. Step 2, assign accelerations and find a relation between them. Then we have to use constraints. No, Anish, that's not the answer. So constraints, since there are no angles here, there is no problem. I can use acceleration directly. T into A1, T into A2, 2T into minus A3. That's equal to 0. So we get A1 plus A2 is equal to 2A3. This is your equation 1. Then write the force equation for this. T minus mg is equal to ma1. So here I can clearly see A1 is T by m minus g. Second block, T minus 2 mg is equal to 2ma2. So A2 will be T by 2m minus g. 2T minus 3 mg is equal to 3m minus A3. So A3 is equal to g minus 2T by 3m. Take these 3 guys and put it in equation 1. So that, I can eliminate A1, A2, A3 and go. So when I do that, I end up with T by m minus g plus T by 2m minus g is equal to 2 times g minus 2T by 3m. Bring all t's to one side, you end up with T into 1 plus half plus 4 by 3. And the other side, you end up with 4 mg. This would give you tension is 24 mg by 17. 3 by 2, 339 plus 8. That's your tension. Once you got the tension, put them back in the, put it back in this. So if you substitute the values there, you end up with A1, which is T by m minus g. That's 24 by 17 minus this. So that's like 7 g by 11. A2, that's 12 minus 5g by, I think that is 17. 7g by 17 minus 5g by 17. Minus indicates my direction is wrong. It's not going up, it is going down. A3, 17, 3, 51, 50. 2t by 3m, no? 3, so 8 to 16, g by 17 plus, so my direction is wrong. It is going down only. That's right. So clear with this. So you have to be little smart, like understanding how to solve. Because the idea was this, every term had a tension. So if you can replace A1, A2, A3 with tension, I'll get tension first. No equation had A1 and A2 together in any one. So this is what I'm saying. So if you don't solve a question till you get an answer, you will never learn I can do like this. So exam mein suddenly when you get the question, you will start scrambling like, oh, usko kaisa solve karo. You'll waste time. Solving is also a skill. And that you can't figure out in the exam. You have to figure out in while practice. But this is how you do this. But there's a much better way. But any doubts on the standard process? Standard process should be always clear because all the tricks and techniques that you learn, by chance you forgot in the exam, right? Your standard process will be always there to save you. वो important है. Exam में like something doesn't click. That's why I keep telling you that 4 steps repetitive. Now listen to this thing. This is a very useful one. We call this thing pulley equivalent. So the idea is this. Suppose if you take a ceiling here and if you take a block M1 here and if you take M2 here, the Atwood machine. Here the tension was T, here the tension was T, and here the tension was 2T. We know tension T is 2 M1 M2 by M1 plus M2G. So I know I can't take this as a single block M1 plus M2, but still I feel like I want to take a block. So I'm saying, okay, let's replace this with one block of M equivalent, where the tension will be 2T. So this would be M equivalent into G. So when you do this, we get 2T is equal to M equivalent into G. So we end up with M equivalent is equal to 4 M1 M2 by M1 plus M2. Or 4 by M equivalent is 1 by M1 plus M2. That means look at the difference here. So if I replace this entire pulley thing with this block, tell me one thing. Does the ceiling know the difference between whether there is a block here or there is a pulley here? Ceiling will only think, "Arey, someone is pulling with 2T. I don't care who is that 2T. How is the 2T coming? Is it coming due to a block or is it coming due to a pulley system? We don't know." And interestingly, right, here I took it rest, but you can prove the same thing even if the system is accelerating. You can take acceleration A and you can prove this. You'll get the same answer. So this is valid even if the pulley is accelerating. You can say verify if you want. You can just take A, and try to do it and finish it off. So this whole system is going with A, then we will put something called a pseudo force and can get it done. So don't worry about it. It comes. I have checked it, but you can verify on your own if you want. So this is valid even if the pulley accelerates, and that's the best part. So whenever you have something like that, you can just replace that with one single block and you can finish it off. Now let's try to use that here and see whether we are getting it. So we call it pulley equivalent. So this was 3M. This is 2M and this is M. So this thing is not equal to 3M, but it is something else. So if I replace this with M equivalent, this is 4 times 2M into M by 2M plus M. So this guy is equal to 8M by 3. So I can replace this whole thing on the RHS side with one block. So this is a block of 3M and this is a block of 8M by 3. This has become an Atwood machine. This is tension and this is tension, and I know how to calculate that. So tension will be 3M, 2 into 3M, 2M1, M2, 8M by 3, 8M by 3G. That turns out to be 3, that's 9 plus 8, 17. 3 will cancel, and that would be 48 mg by 17, which is right actually, because this tension was 24 mg. This was 2T, which is double of this, isn't it? And what about the accelerations? I can use all my Atwood machine ka formula. It has become a 2-block problem. Max doesn't care, like as long as the equations look same. So this is 3m minus 8m by 3, m2 minus m1 by m1 plus m2. G by 17. Great. We got it. Then how do we get for the remaining guys? We know the tension already. We know if this is tension T, then this will be T by 2 and T by 2. So draw the free body diagrams of m and 2m separately. So for 2m, this tension will be T by 2, which is 24 mg by 17. Your weight is 2 mg, and this is your acceleration A2. So once you know the tension, you can draw the FBD for each block and you can finish it off. 24 mg by 17 minus 2 mg is equal to 2 ma2. That's minus 5g by 17. Got it? So that is how we find the acceleration for other blocks. Sure with this? So that's the thing. So if you have a 3-block system, you can replace that whole thing with M equivalent, and then it becomes an Atwood machine, and then you can figure it out. Got the idea? It saves you time from equations. So let's see one like this. Now you guys try. I'll give you a similar one. Four kg, 1 kg, 3 kg, 2 kg. Find the acceleration of the blocks. If you try to do it normally in our process, you get 4 FBDs, 4 accelerations. Can be done. You'll get total 5 equations and you have to solve them. But with our fully equivalent method, it can be done a little faster. So give it a try. Main thing is this. Once you get the tension in the string, then you can draw each block FBD separately and you'll get the accelerations. So calculating tension was the key. So it looks like 5 and 5 on both the sides, but it is not. Try. Take 2-3 minutes. Get it. Everyone should try. It's a little work there, but can be done. So A1, A2, A3, A4. So there are 4 answers. Try. Think whatever you can. Meaning, I already taught you both the ways. So One more minute and then I'll show you. Okay, let's see. So there are two pulleys there, so I'll replace both of them. So this guy ka mass equivalent, I'll call it M2, which is a 2 into 3 into 2. So sorry, 4 into 4 M1 M2. So 4 into 3 into 2, 5, 3 plus 2. That is 4, 3, 24 by 5. This whole thing I'll replace with one block. I'll call it M1. 4 into 1 by 4 plus 1. That is 16 by 5. This itself is a simple question. Huh? They'll ask you which pulley will go down, P1 and P2. It looks like both sides it is 5 kg, but it is not. The right will go down. That itself would be a simple question. So this whole thing can be replaced with two blocks now. M1 and M2. Told you the key is to get the tension. Once you get the tension, job's over. So, so we are finding basically this tension T here. That would be this tension in an atwood machine. So we get tension T. This will be again 2M1, M2. That's what I said. Remember that atwood machine ka formulas. They'll be useful. You can just repeatedly keep using that formula, 2M1, M2 and stuff. So the tension in that string will be 2. M1 is 16 by 5, 24 by 5. G, I'll leave it as G for now. You can actually convert it also. 10, big deal. M1 plus M2 is 24 plus 16. So that is 2, 16, 24, 5 into 2. That 2 will go off there. So you get a 2 there. 1, 5 is sitting here. And that is 40. This is 24 by 5. That's 40 by 5, and that is 8. Perfect. So it's that is 2's 24 into 8. That's 192 by 5. That's the tension in the string. Clear with this? 192 by 5. I think so. Yeah, 96. So 192 by 5. So we got the tension. Great. Now what? You're done basically. Once you got the tension, just go back to the normal picture again. So this tension will be T by 2. This weight will be 40 newtons and this acceleration will be A4. This will be T by 2 and this weight will be 10 and this acceleration will be A1. This is T by 2 and this weight will be 30 newtons and acceleration is A3. This will be T by 2 and 20 newtons and acceleration is A4, A2. Just write the FBD for each one and you're done. So that is T by 2, which you know 40 newtons is equal to 4A4. T by 2 minus 10 newtons is equal to 1 into A1. T by 2 minus 30 is equal to 3A3. T by 2 minus 20 is equal to 2A2. Substitute take a value, you'll get your answers. Is that clear, everyone? So the main thing was to get the tension. If you get the tension, then you can take any block and you know all the forces on the block. You know the tension and mg and you're done. So when you see, and so be careful, it should be hanging like this. That is a catch. You can use it only for this kind of things. If someone gives you like this, let's say there is a block here. This side, there is a string and there is a block. And now you can't do. There is still a way to do. If you fix it here, we can assume this is an infinite block. Isn't it? That's like a huge infinity block. So then it is 4 by m equivalent is 1 by m1 plus 1 by m2. So one is infinity. So one is infinity and other is 1 by m. 1 by infinity is 0. So this is 4 by m equivalent. So m equivalent is 4m. That means you can replace this entire thing with a 4m block. So making sense? A fixed point is as good as saying it's not going to move. It's an infinite block. So you can still do, but there you have to do little modifications like that, but can be done. All clear with this? Now, the actual question. All this I taught you for this. So we got a block of mass m here. We got a pulley here. We got a block of mass m. We got a pulley here. We got a block of mass m. We got a pulley here and mass m. And so on till infinity. We have infinite pulleys. Find the acceleration of this block. Uniform gravity. Let's get this. You have infinite pulleys on the right side. This problem, think, I'll give you a minute, think about it. Then I'll tell you something, then I'll give you more time. Think whatever you will do. All blocks have same mass m. There are infinite blocks. Yeah, right, Anna. So this problem, right, was actually inspired from a max problem. If you remember this, y is equal to root over x plus root over x plus root over x plus so on till infinity. Did you guys do something like this? And then we say, since this whole thing is in infinity, if you remove one x from there, that is still x. So we can write this y is equal to root over x plus y. Because this whole section will be still y. And then you'll square this and you'll get y square minus y minus x is equal to 0. You get a quadratic and you solve. So then, so the problem was inspired from this. So using this inspiration, right, actually it came in a physics Olympiad. There is a problem on resistors, which looks like this. Using that problem, this problem was inspired. So end of the day, the inspiration is this max problem. Now see if you can get any ideas from there. Right, Anish? You have two answers. Right. That's what you have to do, Anish. So what's the idea there? So we start like this. Let the whole right side infinity wala, this whole thing, let this whole thing be x. I don't know how much is this. Let this be x. Great. Now, if this whole thing is x, from there, if I remove one pulley, and if I say this whole thing, so infinity minus 1 is still is infinity. So this is also x. Agreed? So from the whole system, if I remove one block, it is still x. So that means now your picture will look like this. M on this side, this is M, and then this was X. But what did you say? You said this whole thing was also X, isn't it? You said that whole thing was X. So M equivalent was X for this. But what is M equivalent ka formula? M equivalent is 4 into M into X by M plus X, which should be equal to X. So we get 4M is equal to M plus X. Therefore, X is equal to 3M. So this whole infinite thing on the right side is equal to a 3M block. You get the logic there, what we did? We started with the thing, let the whole thing be X. If you remove one block, it is still X. So this M plus X ka resultant is the M equivalent. That should be equal to X because that's where you started the problem from. Have a look at this. I hope it's not confusing. That's the idea there. From an infinity, if you remove one branch, it will still be an infinity. And then, yeah, you're done. So this whole equation has become like M. This has become like 3M. And you're asking for this acceleration. 3M minus M by 3M plus M into G. And G by 2, and you're done. Suppose if I had asked you this acceleration is block, how will you calculate that? What you would do for that? So this is what I got. How would you do for that? Acceleration for that block one branch below. It's a good one. Like once you know the pulley equivalent method and this infinity thing, this becomes really easy to do. But if you don't know these two concepts, this will look like what the hell. Today there'll be no break. Huh? I will be leaving you a little early anyway. My throat is actually it's gone for some reason. We give that pulley an acceleration of G by 2. I don't understand what you said, but Anish, I'm not clear what you said. Hmm. So how to do? Remember this thing. Whenever you want to find acceleration of any block, find the tension. The game is always with the tension. So find the tension here, T. So tension T will be 2 into M into, if you know the tension in the string, you can calculate acceleration for any one. So don't look at the acceleration, look at the tension. This would be how much? 6 mg by 4, that is 3 mg by 2. That's the tension in the upper block. Now, just draw the thing again a bit. So you want this block, right? So if this was tension, the same tension, this guy would be T by 2. this would be mg, and this would be your acceleration a2. So t by 2. So if you want for the next block, it will be t by 4 and so on. You just have to split it. M into a2. So this is 3 mg by 4 minus mg is equal to m2. So a2 will be minus g by 4. It's actually going down and not up. Got it? You can keep playing this game. I can find the acceleration for this guy, anyone. As long as you know the tension, you can find acceleration for anyone. But it's a good one. It's a really good question. This is the kind of thing you can get in advance. All clear with this? That's an infinite pulley thing. Great. Before going ahead, let's do one more where none of these things work, because I don't want you to think like har baar use kar sakte hai. You should know there are certain cases where nothing works. You have to go back to your process. This is capital M, this is small m. Find acceleration of the blocks. So you can't use net pulling force method. You can't use pulley equivalent here. So yeah, you go back to the process. Let's get this. FBD, constraints, equations, solve. It's slightly lengthy, so to give it a try. Yeah. Let's do step 1, free body diagram. Let's start from here. Let this be tension T. So this guy will be T. This will be 2T. Then this will be 2T. This is 4T. This will be 4T. This is small mg. This is capital Mg. Step 2, assign accelerations. I think this guy will go up. I think this guy will go down. I'm thinking. Find relation between them. String constraints T into A1, 7 times tension into minus A2. A1 is equal to 7 A2. Never assume they're equal. Always assume A1, A2. Let the constraints tell you if they're equal. If you're confused, that means they're not equal. As simple as that. You see a question and you feel like, yeah, they're not equal, meaning you get a feeling like, is it equal or not? The moment you say, is it, means it is not. Keep it simple. If it is, you will know. Then put the constant that will help you out and write the equations. For the big block, it is 70 minus mg is equal to m into minus a2. I'm following the sign convention strictly, up positive, down negative. I know you can take mg minus 70, but yeah, once you become later on, once you're comfortable, you can do that. Great. Take a1 here, substitute in this. You get t is equal to mg plus 7ma2. Take this t here and dump it in this. 7mg plus 49ma2 minus capital Mg is minus capital Ma2. So A2 will be M minus 7m into G by M plus 49 small m. Please check your answer. Clear with this? No. Let me show you some method. It's a little lengthy and long. I never use it, but it's not a bad method. If the system is very weird, you will get an answer. It's like you filter out everything and you get an answer, meaning the understanding is zero, but you'll get the final result. So it's an interesting thing. So we'll still do it, but I too don't remember it. So even I have to derive it. Up to you. I will leave it to you. So look at this thing. Consider we have n strings. So we have a system with different strings with different blocks. So we are taking the most variable thing that's possible. So let's say C1 into T. So this is the tension in the first string. If I say Cn into T, this is the tension in the nth string. So C1, C2, Cn are the coefficients. They can have any numbers, anything. So Cn is the coefficient of tension of the nth string. Similarly, let Mn be the mass of the nth block. An be the acceleration of nth block. Perfect. Now, if we use our power method, if you remember, the power method says T1A1 plus T2A2 and all that stuff. So this will be C1 T into A1 plus C2 T A2 and so on till Cn T An must be 0. This is equation 1. Now, this is valid only when the angles are 0. So I'm not even taking that angle there. Valid when only strings are present and angles are 0. Tension and acceleration is 0 or 180. Great. Next thing, if you take the block, any block, now the force on this will be Cn T. This is Mn. So this mass will be Mn G and this acceleration will be An. This will be Cn T minus Mn G is equal to Mn An. This is your equation. So from here we get AN will be CN tension by MN minus G. This is your equation 2. Now we take this equation 2 and put it in equation 1. So when you substitute here, so the equation 1, I can write it as sigma C subscript I, tension is common anyway. So Ci, Ai, tension is 0. And equation 2, what we got was Ai, that's the acceleration of an ith block, is Ci, tension by Mi minus G. So take this and put it in this equation. Then you end up with sigma Ci. So take Ai from here and substitute here. Ci by Mi T minus G into Ci into T is 0. Expand this. This would be Ci square. So the T is anyway useless, so one T will go off. Is equal to 0. So there, from here we got the tension T if we take T common from there, we get sigma Ci square by Mi minus G sigma Ci is equal to 0. So that we get tension is G times sigma Ci. C is the coefficient of the tension by G by sigma Ci square by Mi square. So if I expand this formula, this looks like C1 plus C2 plus so on till Cn into G, the coefficients of tension by C1 square by M1 square plus C2 square by M2 square, so on by Cn square by Mn square. This gives you tension in the string, any string. Meaning, if you see this thing, right, it's a completely filtered version. I don't care what block, what it is doing. This takes care of everything. So this T here is the tension in any string that we choose. So you start with T there, and I'll show you an example. The tension in any string of a R choice. You choose whichever string you want as T, and you can do this. Just have a look at that formula. You can put it down. Again, I did nothing new. I used the power method and took a general blocker equation and I replaced it. Technically, working is that much only. The way it looks is a little bad. But yeah. So let me show an example. You want, you can put down that thing, but yeah. Look at this 3-block problem which we did. I will never use in the exam. It's difficult to remember that, but it looks nice. If you get some really weird thing, it will help. So let's say this is 3m, 2m, and m. Perfect. So let's decide where you want to find the tension. I want to find this tension. Perfect. You want to find this. So that is T. If that is T, this is T by 2 and this is T by 2. Great. So what is the coefficient of tension? This is 1 times T. So this is coefficient of tension is 1. What is the coefficient of tension here? Half. That's the meaning of it. Before T, what do you have? It's an half into T. Perfect. So what is the formula for tension? Tension, sigma Ci, so coefficient of all into G by sigma Ci square by Mi square. And Ci square by, this is not square, this is just M, sorry. M. Perfect, apply the formula. So what is the coefficient for this? 1. What is the coefficient for this? Half. Coefficient for this? Half into G. by what is the coefficient for this? 1. And what is the mass? So 1 square by 3m. This coefficient is half square by 2m. This coefficient is half square by m. So numerator becomes 2g. Denominator becomes 1 by 3 plus 1 by 4 plus 1 by 4. That's 2 mg by 1 by 3 plus half. Maybe I cooked up somewhere. This is 1 by 8. Hmm. That's 1 by 3 plus multiply 2 and 2. That is 3 by 8. So that will go up, which is 48 mg by 8 plus 9. That's 17. Isn't that the tension in this block? Once you got the tension, then you can find the accelerations and you know the story. Are you clear with this? That way, this helps. Matlab, the thing with this, right? You don't care what is the FBD, what is the acceleration, everything is filtered and everything. This you will lose all understanding. You'll get the answer though. But like again, it works for these kind of things. If they mess up some angles and all, you always have to go back. So if you're doing a question like this, even for this you can do. So remember, T is the tension on the block. So for this block, what is the total tension? 7T. So the coefficient is 7. You can directly put it and solve. You'll get it. The T is the total tension on the block. Is this clear, everyone? Let's do one problem on this. But can you put down this formula? You will need it. Just copy it down on the side somewhere. So let me just give one weird thing so that we can do. Copied? This is not compulsory. If you are fine remembering, great. If you can't, the pulley equivalent and the standard method is sufficient to handle most of the problems. Until unless someone really goes crazy and tries to irritate you guys. Yeah, someone made it something like this. I don't want anything. I just want to find access of this block. I can't use pulley equivalent, right? I can use the standard method, tensions and stuff, but I have to get 4 equations and one string constraint and 5 equations and solve. Sure to get it. But you will see. If you just want access on that one particular block, means I want tension in this particular block. So start with that. Let that be T. From there, get the remaining tensions. Get the coefficients. Put in the formula. You'll get T ka value. You're done. Once you got tension, you'll get the acceleration. It saves you a bit of a time. So what we did was actually you wrote equation for n blocks and n constraints and you simplified it and it looks like a shortcut. It is not. You have literally used the general method and we got that for n blocks. So start from here. Let this be tension T. Get remaining all tensions. Get you want the coefficients. The T का पहले जो number and then you're done. Anyone got the tension? 4G by 11 it seems. I don't know. I just made up this. So someone else had to verify it for me. But I'll get the tensions. You can check whether you got the tensions same. So let's start from here. Let this tension be T. If this is T and this is also T, this guy is 2T. This is T and this is T. This guy is also 2T. This is T. So this whole thing is the same string. So this is also T and this is also T. So this guy has 3T. Now the formula tension will be sigma Ci into G by sigma Ci square by Mi. Not really that difficult to remember, but yeah. The coefficient of, let's start from the left side. Iska coefficient is 2. This coefficient is 1. This coefficient is 2. This coefficient is 3 into G by denominator. This coefficient is 2 and the mass is M. So you should take that coefficient and that block, which is 2 square by M. This coefficient is 1, but the mass is 2M. This coefficient is 2, mass is M. This coefficient is 3, mass is M. Check. That would be 2 to 4, 5, 8, 8 mg by this is 4 plus half plus 4 plus 9. Yeah, that looks bad. That would be 16 mg by 9, 4, 8, 17, 35. Yeah, that's your tension. Once you got the tension, take the block 2m which you want to find. That would be tension. That would be 2 mg and that's your acceleration. Substitute here 16 mg by 35 minus 2 mg is equal to 2 ma. That doesn't look really that great. 35 to 70, 70 minus 16. 60, 54, 27 g by 35. Check. Any doubts on this? So it saves you a lot of time. So there you have total 3 things. Did by the power method, yeah. You'll get 4 accelerations, A1, A2, A3, A4. And you'll get 4 equations, so total 5. So yeah, so check it out. Looks though right what yeah. Kind of saves time. So it's not really that bad result, but when things are really bad, it works. All clear with this? So there I taught you 3 things. You know the general method, you know the Pulley equivalent, and you know this thing. All clear with this. Let's see, one last one for the day. This is capital M, this is small m, this is there, this is the string. I'll mark it in green. See, the string is going like this, and like this. So this, the whole green thing is a string. All surfaces are smooth. Find acceleration of the blocks. We did this thing in constraints. We also did this thing in FPD. So you already know how to do constraints. You already know how to write FPD. It's just a matter of writing equations and solving. Finish off. Process is still the same. Step 1, choose a system, draw the FPD. Step 2, assign accelerations, find relation between them. Step 3, resolve your forces along x and y, accelerations along x and y, write equations. Step 4, solve. I'll keep saying the same thing like a broken tape recorder, at least for the next 3 chapters. Friction, circular motion, same thing. And that's the best thing. Matlab, if you're going to say the same thing for so long, meaning it is so, standard, you should not be able to forget. Even in the exam, when you're under pressure, you should be able to still perform. That is the advantage of things which are like repetitive and boring. Hmm. Get me the acceleration of the small block now, or the big block. Do we take acceleration of M as A? So that's your choice, right? You can choose anything you want. You have to start assuming it's something as A. Yeah, generally we take the big guy as A. Hmm. Okay, let's see. Step 1, choose your system. So yeah, just draw them separately because if I draw on them, it gets confusing. So let's take the big guy. Remember, you have to include the pulley always. The pulley has a rod and it is fixed inside, so it is a part of the system. Forces, tension, tension. If you don't write the pulley, you will miss those forces. Then you have to write the force due to the rod, which is confusing. So this is tension. This is normal reaction. This is your own weight mg, and this is n ground. Check total 6 forces. Most people mess up 1 or 2 forces. You have to be careful. If you can draw your FBD properly, constrain properly, question is actually over 70 to 80%. Normal reaction. These are all the forces. Next thing, acceleration. If this is going forward with A, this also will go with A forward and it will come down with 2A. Remember, we proved it. So every time it goes front, it will go down with 2A. In case you forgot, we did it here. Page 31. There. We proved it will go with 2 yuga speed. So I will put that as a reference. You can check it out. Page 32, NLM. Same chapter. You're done. You know the constants and stuff. Write the forces horizontally. 2t minus n is equal to mass into acceleration. Here n is equal to small m into a. And here t minus mg is equal to m into minus 2a. Perfect. Take n, take t, dump both of them in this. You'll get 2 is equal to mg minus 2ma. N is equal to small ma is equal to capital Ma. Take out a common. That would be 2mg by capital M plus 5m. You're done. So the small block is going a I cap and 2a minus j cap. A ka value is this. Do have a look at this if you have messed up something, forgot something, see where you forgot. One common mistake I see, people forget these tensions here. So maybe that could be a mistake. You have to include the pulley. Second mistake generally is they think this is also A. So yeah, those are the two things you have to be careful. Rest is fine. All clear with this. So that's a bit about it. So next class when we catch up, we will do few more on this and we will go ahead with springs in the next class. We will do more on springs. I think we should be able to finish all the chapter in another 1.5 class. And after that, we'll start off with friction. But this is the theme. Whatever I taught you in NLM, exactly same thing will happen in friction. उसमें सिर्फ extra एक force आएगा friction. So there the story will be like this. Draw an FBD. This time also include friction. Step 1. Step 2, assign accelerations, find relation between them. Step 3, apply forces, solve. So friction will not look any different than NLM. Extra, there is one force. That's it. It's like, if you ask me, right, this is how I think. Loss of motion is like plain dosa. Friction is like masala dosa. First you make dosa and put that potato thing and suddenly becomes a masala dosa. So it is something like that, right? And your circular motion is like onion masala dosa. You make dosa, put potato and then put onion and it becomes a new dosa. So NLM is your base chapter. Like everything you just keep adding on top of it, but everything is connected to NLM at the end of the day. And in NLM, the two base things are constraints and FBDs. And we spent a good amount of time on that and to practice them. As long as these two are strong, the chapter will hold itself. You can be able to handle it. You can see every question. See, I'm drawing an FBD, I'm writing constraints, and then the question is done. So we did almost 39 questions, everyone. So please go through all these 39, resolve them once. You can start solving. If you have not solved anything on NLM, please start solving. If you have already solved some part of it, maybe I'll send you a sheet on this today. You can give it a try. Okay, that will wrap up for the day. My throat is a little bad for some reason. I'll see you guys again on next Monday. We'll continue from here. So next week we will finish off NLM and start off with friction introduction. So, okay. Any doubts? Anything else? Stay back and ask. And do remember there's a test online on Friday. So make sure to give it. So yeah, take care.